Hello guys, welcome to this new video on Karamba, and in this video I will be explaining you about the structural calculation done on a facade. So as you can see here, this is my facade on which I will be calculating the deformation and the wind load utilization factors on Karamba. So as you can see the dimension of my facade on this image, the same dimension I have recreated it on the Karamba. So in this video you will see how to make this model in Karamba and how to put the glass weights on these panels and how to also put wind loads as uniform live load acting on this mullion. So as you can see on the right side, this is already pre-made, which I'm showing you. So this is how we are going to do it. The steps are: first we will create a basic structure layout. That is how to make this layout of this transoms and mullions, and then we define them in this part, and we define their cross sections in this part, and this part we create the supports for the mullion. That is, the top support is fixed and the bottom support is moving support. And here this model is analyzed uh, after adding all the supports, cross sections, material, and here you can see this is also for creating supports. This is not for supports, sorry, this should be edited. This is for creating loads acting on the structure. Okay, and yeah, so this is the generating and analyzing model, and this is the final result table what we are going to get. And here we can see here different parameters. So I can get the displacement. So here if I click on the displacement, I can see here the maximum displacement happening on this model. And if I click on utilization, I can see what part is maximum utilized, which is red. Here you can see 44.3%. The red part is in the center, as you can see here. So this part is the maximum utilized part. And yeah, so this is how we are going to calculate. The actual stress also is possible for you to get here in the table, and also the displacement. So let's start with the first step. I want to create all the node points for my structure. So I will click here the single point option, and I'll enter 0, 0, 0. This is the origin, and the next point I want is at 780 mm higher from here. So I'll enter 0, 780, 0. So as you can see, the next point is created here, and after this the point which I want is 2.82 meters high. So I will enter 0, 2820, 0. So the third point is created here, and the next point which I want is 3.6 meter height. So I will enter 3600, 0. So as you can see, I created a set of 4 points. This is for one single mullion. So I'll select all of them, I'll copy it, and I'll paste it here again, and then I move it from this base point to here 1780 mm far. So yeah, And the same I do for the next set of points. I copy these points and I paste here, and I move it from this base point to 1780 mm far. Okay, so here the problem is that this part is really small, and when finally you try to make your render, it is too large. So I would like to change the dimension here. So by going in the annotation styles, I'll go to the units. I'll change it to meters, and I change it, scale it. So okay, it's taking time. So as you can see, our model is now in meters and it's really small here. So this was the first step to create all this node points. Now what we are going to do is create points in Grasshopper so that we can assign all of these nodes. So I'll copy this. So the option to copy this is left click mouse, select and press Alt, and you copy it. And then you can rename it maybe to B. And so I have 3 into 4, 12 sets of points. So I'll copy this again, made 4. Now I want this 3 times more. So here 1 time, here 1 time. So it's total 12 points here. So now then you can rename all these points. Point C, point D, point E, point F, point G, H, point I, point J, point K, and point L. And now the next function we need is line. So I select this line option, and here we have a start and end point option. So by selecting 2 points we can make a line, but right now these points are not selected. So let me select these points. So this is the first point, so this is the second point, third one, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So as you can see now, if I select any of these points on the left side, these points are highlighted as green. So now what I do is, okay, so I see here I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. So I have to create 13 line function. So I'll do the same. I'll click the left button, Alt, copy it. Same I do again, left button, Alt, copy it, and do this 3 times now. Sorry. So I created 12 lines, and I'll copy this again. So this is our 13th line, and I can move it a bit up. Okay, so now I want to create a line between A and D. So I'll select point A, point D. So I created the first line here. So you can see the red line. And now the next line I want is from point B to E. Okay, so now afterwards I want a line from C to F. So I keep on creating these lines I require. D, G, E, H, F, I, G, J, H, K, and I, L. So I created all the vertical lines now, that is the vertical mullions. Now I'll create the transoms. So for transoms, I need the point D and E. So I need to select D from here, E from here. I created a vertical line. Now I need E and F. So I'll select E and F. And then I need G and H. And H and I. So now I created all the line elements and all the nodes on which we can create our mullions and transoms. So this was the first part of creating the structure. Now let's go to the second part of the structure. Before that, I would name this. So I will put here a scribble, and I'll name it as the first basic structure layout. And then I select all of them and I go to edit and group them. So all of them are in a box. So now I can move all of them with this box. So this also was a shortcut for you. And now the next step for making the mullions and transoms is that we need to first create line to beam. So for line to beam, that is we need to make this line into a beam. So we enter line to beam option, which comes in Karamba 3D, and you can select this option. So we have 3 vertical mullions and 2 horizontal transoms. So what I would like to do is I'll create 3 different mullion IDs so that I can have every deflection of the mullion separately in my model analysis, and also 2 transom IDs so that I can see 2 different deflections for my transom. So what I'll do is I'll copy this 4 times, not 4 times, 5 times, because we have 3 mullions and 2 transom IDs. So left click, Alt, left click, Alt, left click, Alt, and now we have created line to beam function, but now we need to get all this line connected to the beam. Before that, I would like to name all my beams. So this is a shortcut. You can put this quotation mark and then you can type this as mullion 1. So you get directly a panel of mullion 1 and you identify now this mullion 1, this line beam as this mullion 1. So now I select this panel again, copy it here, do this again, and yep, here. So now this is going to be mullion 2 and I'll connect it to the identifier. Mullion 3 connected to this identifier, and this will be transom 1, and this will be transom 2. Okay, so I connect them to the identifiers. So these beams are known by these names. So before that, when we want to put this line data into this, so what we have to do is, as we know, mullion 1 has 3 different line elements, that is this line, and this line. So we need to put all these 3 lines, that is this one, this one, and this one. So yeah, I need to put all of these lines into this part so that these are represented as mullion 1 part. And what I'll do for that is I'll enter a data. Okay, so this data part will be here, and now I will get all the values of this line using this skull end function. So what it does is it takes a list of all these lines. So this is the first line, second one, you have to press shift and add again. This is the line. So I've selected all the mullion ones. So now when I press this, you can see all the parts on the first elements are selected. So yeah, so then I put all these lists. So as you can see, yeah, I've selected all these lines into this list, and then now I put this list into this data. And here, as I have this three lines, my cull frequency will be 4. So I keep the frequency 4. So what I need to do is I need to do the same for all these remaining 4 elements. So I click and copy this again 4 times. So now I will disconnect all, disconnect all, disconnect all. So now what we have to select is only the mullion 2. So mullion 2 is this one, this one, and this one. You have to press the shift button. So as you can see, this is the first line and this is the second line here on the left side. And the same I do here now for the third mullion. So third mullion is this part, this one, and this one. So as you can see, all of them are selected. So here, as I have 3 elements, I only put the cull frequency number as 4. And when I have, okay, I didn't copy here. So here I have 2 elements. So my 2 elements for the transom. So the cull frequency will be 3, always 1 higher than the total number. So now I select all my transoms here. This will be my transom 1, and this will be my transom 2. So I put all this data into this line to beam function, and this is the main second part of defining the mullions and transoms. So the now next thing what we are going to do is all these elements, these line to beam are in form of an element. So after putting all this data, I will create a modify element. So this is a function in Karamba where you can put all this beam into a single structure. So as you can see now, all the beams are selected into this modify element, and I have all the values here for these elements. So I will now select, so first I will scribble here. I will write this as defining mullions and transoms. And then I select all of them here and group them. So this is my second group where I define mullions and transoms, and I have all the elements here. Okay, now the next part what we will be doing here is generating and analyzing this model. So let's enter assemble model function. This is a Karamba function. So now here you can put all your elements, that is this element which it's going to analyze, and for analyzing you need to press analyze Karamba 3D. So this function analyzes your model. So this part, as I said, is for assembly model and analyzing this model. Okay, so now the next thing what I will be doing is I will create a scribble for this part. And I'll write here generating and analyzing model. And select all of them and put it into a group. So this is our generation part. Now other than this we have to create the loads and supports. So first I will go with defining the supports. So let's create support in Karamba, and this is the support we require. And we require it twice. So I will be copying this again, left click Alt, and I will connect these supports here. But right now we haven't assigned the type of supports. Okay, so I have created two supports here. As you can see, this is a fixed support, and the next support I want to create here is moving support. And for moving support you only select rotational X and fix it from all directions, and you give degree of freedom in Y and Z direction, so it can rotate in Y and Z direction. So now the next part what we want to do here is create the material. So we make a material for this model. So I'll put this material here inside this option in the assembly model, and then I'll select aluminium, and this is the requirement as per my topic. So I will select this one. So now I've added this material inside this, and now next what I need to make is So here, as you can see, it's analyzing the model, but so I guess we are not able to see here the position on the model because we don't have a model view. So I will be creating a model view. So I select this calculated model and put here. Now you can see the support here. So now no tags. Okay, now you can see which one is the support here. So you just need to enter. So all the top part of your facade will be fixed. So I will keep the support 3, 5 and 11 as the fixed support, and all the bottom supports will be only fixed in the X direction for the rotation, and will have a freedom to rotate in Y and Z direction. So I create this panel again here and copy this. Now I will change the value of this to 078. So I copied all these values here and I created the supports here. So yeah, you can see because of this model view, so you can keep on checking everything here like element tags. So what is this element? This element is 914, and you can write the element IDs on top of the structure, cross-section names, everything you can put in here. So yeah, this is a cool option to put more details on your structure. So I have fixed the supports right now here, and I have assigned a material. So the big part here we have completed, that is defining the supports and material. So I will scribble here a bit, scribble here. This is going to be our part where we are defining the supports and material, and then I will select all of them and edit here and group them. So this is one of the major group of defining the supports and material. So next part what I will be doing is I will be creating loads on the structure. So for creating load, okay, so for creating loads on the structure, there's an option called as loads. So go to the loads Karamba 3D here, and you have to create 3 different types of loads on this entire structure. So I copy this 3 times. Okay, so the first case will be the simple gravity where the L case will be 1. So I connect this to the loads. So gravity is acting on this entire structure. And the next type of load here will be uniform line load. So for uniform line load, I'll select this uniform line, and I need to select all the beam IDs on which this load will be acting. So let me first create the wind load. That is, okay, so I create this uniform line load and have to select global. And now the next part is I need to create a Z vector and connect it here, and then enter a negative value as my wind load will be acting in the negative. So my wind load is assuming 0.36. I put this value here, and this value is taken here, and this uniform load will act on all the beam elements whatever you select. So just to put my beam elements here, I'll make a panel with my beam name, and then I will do it as a multi-line data. And okay, so now I'll enter all the mullion on which this load will be acting, and it will be also acting on this transom. And I forgot to add transom 2. Okay, transom 2. So now I connect all these IDs to the beam, and now we have assigned all of them, but here you cannot see it because I haven't put the load. So I'll put the load in the model, and now you can see this force acting on these beams. And yeah, on transoms and beams the force is acting here. So we assigned uniform load. Okay, so the gravity got disconnected, so I'll connect it again. Okay, now this got disconnected. Yeah, so we have now wind load acting on all the mullions and transoms, and gravity acting on the facade. And the third type of load now we have here is that is also a uniform line load. So uniform line load, and this will be acting along y direction as the glass load. The load which will be transferred by the glass is going to be added here. So I'll enter the transoms on which this loads will be acting. So first I need to check which transom I need to assign, because I need to assign on this bottom transom on which the big glass will be resting here. So I go here and check which one is my bottom transom. Okay, so transom 1 is my bottom transom, so I will write here transom 1, on which I need to put this load, and then I'll assign this first. So now I need to make the load. So first I need to make a vector which is in the y direction. Okay, so it is selected here. Next it will be negative vector which is selected here. Now the value what we require is for the glass, so we need to evaluate the glass weight. So I'll select this. Now the type of expression we want here is first variable will be the height of the glass. Second variable will be here the thickness of the glass, and then you can put on more variables. We need two more variables, and this is the okay. Okay, so this is the height of the glass, this is the thickness of the glass, and this is the density of the glass, and this is the gravity of the glass. So we are going to evaluate all of them. So let's put it as data, and here I will rename it as glass height in meter. I'll copy this and rename this as glass density in kg per meter cube, and glass thickness in meters, and gravity. Okay, so now I connect the height, the glass thickness, the glass density, the gravity here. So I need to define the height here now. So I'll take my height of the glass is 2.04 inside the panel. I put it here. Now the next value I'll take here is thickness of my glass, which is 14 mm. So I'll put in here. The glass density is going to be 2040, which I'll add here, and the gravity is going to be 9.81. So now I will be making this formula here that will be equal to H into T into G into D by 1000. So this is the formula we require for calculating the load. So here you can see there's some error, invalid expression. Okay, so I don't require this equal sign. Now it's okay. So now this load is created, that is the glass load on the transom in the y-axis, and I'll put this load shift to this load. So all the three loads are added now. You need to press shift and keep on adding this load so that it doesn't disconnect at once. And now I can name this as all the loads acting on the structure. So I'll scribble here And now I will select all of it and do the grouping of it. So this is my load acting on the structure, this is the supports and material, and this is the analyzing. And now the next part we want here is defining the cross sections. So we need to define the cross sections for this model. So that will be this part which we require here. So once we define the cross section, we have all of the things ready here. Okay, so now I require to create the cross sections. For this, I will be defining a cross section. So the type of my cross section is a box cross section. So yeah, and it will be for mullion and transom. So I will copy this twice. And now what I have to do here is put my mullion ID and then link all of them here in the element identifier. So all the mullions are now selected here. The same thing I have to do for the transom. I need to create a transom ID and add it here. Okay, so the transoms have different cross section and the mullion have a different cross section. So now the next thing what I need to put here is the dimensions for these cross section. So yeah, but this is in centimeters and we require in centimeters, so I will be putting it here. So 12.4, that is 124 mm is the depth of my transom. So now the next value will be 5, that is the upper and lower width of my transom, and the wall thicknesses of my transom will remain 2 mm. So I'll select upper, lower, and S wall thickness. So all of them are 0.2 mm. So this is how you define a cross section for transom. You select the transom identifiers, you put the height, you put the upper width, lower width, and put the upper thickness, lower thickness. So I quickly show you what they mean by all this. So here, this part you can see here is the upper width, and this is the lower width, and this is the height of the transom, and these are the thicknesses what this cross section command is asking for, so you have a clear idea what we are entering here. Now the same thing we have to do here for the mullion, and For the mullion also, the values are similar, only the height will be 125. So I will be adding here the height, here the upper width, lower width, and here I will be adding the upper thickness, lower thickness, and S wall thickness. So I created the cross sections for my mullion and transom. So now I connect these cross sections to my uh, analyzing model. Okay, so now I will make a modify cross section. What this function will do is it is going to add ixx and iyy for your mullion and transom. So I select these cross section and connect to this modify cross section, and then here I have a part called as iy and izz. So here I can put my values. So I'm randomly putting now some values here, that is 108, that is ix or iy, okay, and 28, that is iz. So I'll put my iy and iz here, and same I will do for the transom. I will put it randomly as 89, and 26. So now we have the IYY and IZZ for all the different cross sections. Now we can add these cross section into our cross section model. That is, sorry, the assembly model. So we add all this cross section to the assembly model, and now we can place all of these things. Making a scribble, I will write here 6 defining the cross sections and I'll select all of these and group them. So this is how I define my cross sections. I have my generating and analyzing model here. So first I create here the supports and material and loads acting on the structure, and then the cross section, which is then added into the analyzing model. Here is my model. So now what you can do more in this model is, when you have this model view, you can do an analyze where you take this model and then you have a model view and beam view, so that you have a clear idea of the deflections and the values acting on your mullion. Here you have the render settings, so you can keep on changing as you want to see the changes in your model here. So now the next part I will be doing here is I will create a beam view So I will take all the model values in the beam view, and I will create a legend. So now you can see here we have a view of the beam, what is happening on the beam and what is the deflection here. So yeah, so this is how you get the beam view, and now you can keep on checking for different things like here cross section. So you want to see the utilization. So this is the utilization of your beam, and if you want to see the displacement you can click this one and you can see the displacement. Now what we have to do more in the results is we need to create a legend so that we understand what is happening and what is happening in our beam view. So here you can see the utilizations now for the entire structure. Here you can see it in colors. So wherever you see red color, the utilization is 43% on the structure. And when you change this to displacement, you can see here as it gets more darker pink, the displacement is more. So you can see here there is a big curve here which has the highest displacement. So that is these values. So you can see all these values here now. And other than that, if you want to calculate your exact beam displacement, so what I mean by beam displacement is there is an option for beam displacement, so where you can put this model, analyze model, and now as you have this data, you can put all the data, that is this translations into this panel. So as you can see here there are a lot of values. So now what I'll try to do here is simplify so that I know which value is for which beam exactly. So here what I'm going to show you now is important to understand what are the values acting on the beams. So first what you have to do here is let us in the model view. Yeah, so here let us in the model view select the element IDs, not element ID, sorry, the element tags. Okay, now you can see all these tags here. So all these values of the beam displacement are as per the element tags. So if you can see here 1, 4 and 7. Okay, so now what you can do from here is you can check the values, the displacement values for your mullions and transoms. So as we know the beam IDs here, so 1, 4 and 7. So 1 and 7 displacement will be the same. So if you see this and this values, that is this mullion 1 and mullion 3. So for that we need to go in this line and this line. So here you can see the value of displacements are same for both the mullions, while the center mullion 4 will show more deflection. So that is here, that value is here for the center 4 mullion. And now for the transom you can do it in the similar way. You can go to the 9 and 10 and 11 and 12. So for 11 and 12 it will be the same, and for 9 and 10 it will be the same. So 9 and 10 you can see here the values are same, exactly same for both of them, and for 11 and 12 as well it will be the same. You can see these values are same for these IDs. So this is how you get the data from here. So yeah, this is the final result, what you get from the Karamba after creating this analyzed model. So I will scribble and name it as the result. And I'll select all of them, and then I will group them. So now what I will do is I will maximize the screen and I'll move all of them maybe here. Okay, so now what I will be doing is I will be zooming out all the parts so that you can take a screenshot for your help. And this is how we did the basic structure, defining mullions and transoms, support and material, loads acting on the structure, generating and analyzing model, defining the cross sections, and this is the final result.